Okay, I think we have enough number of participants to start. Our panelists are here, and I would like to first welcome everybody. Thank you for joining. We will start introducing first Siep Nguyen Van Houte, who is a Senior Manager for Climate Business at the International Finance Corporation, IFC. In this role, she's also Chief Innovation Officer and Chief Operations Officer for key portfolios across industries at the IFC, including green buildings, real estate, green cities, energy transition and efficiency, transport and industrial decarbonization. Diep has been among the early supporters of green hydrogen innovation and development. She commissioned and funded IFC's early project development work on green hydrogen in multiple emerging markets since 2019. Before joining IFC, Diep worked for 70 years as lead technical specialist and chief investment officer at the World Bank for infrastructure and sustainable development sectors. She has worked on more than 40 countries in multiple World Bank Group regions and has provided billions of financing to development projects in emerging markets. Siep, over to you. No, you're on mute, Siep. We cannot hear you.
Can you hear me? Okay, it's great, excellent. Thank you for that introduction, Vanya, and good morning and good afternoon to everyone. Thank you all for joining us for this webinar, which is looking at climate resilience in the built environment. With the ongoing climate crisis contributing to increasing natural hazards in many parts of the world, resilience in the built environment has become a crucial element of sustainable design and development. Today, we're joined by an expert panel, including representatives from Swiss Re, First Street, and our own Building Resilience Index team here at IFC. We'll navigate resilience for the building industry. So first of all, what is resilience? Resilience is the ability to anticipate, prepare for, and respond to hazardous events, trends, or disturbances related to climate. Improving climate resilience involves assessing how climate change will create new or alternate current climate-related risks and taking steps to better cope with these risks. Climate change is directly contributing to humanitarian emergencies from heat waves, wildfires, floods, tropical storms, and hurricanes, and they are increasing in scale, frequency, and intensity. And as many of you have heard or seen, just the last 2 weeks alone, there are events in Brazil that we've heard of, but we literally every week there's a new disaster that we're learning about. Global natural disasters in 2023 resulted in huge economic losses totaling 380 billion, and I actually think that this number is underestimating. So how does resilience apply to the building industry? There are two reasons why resilience is relevant. First, the building industry is the largest emitter of greenhouse gases, accounting for about 40% of global emissions. The production and use of materials such as cement, steel, and aluminum have a significant carbon footprint. Buildings host most human activities and are essential to economic development. They contribute to safety, well-being, and sustainability of individuals, businesses, and communities. So supporting resilience of the building industry is essential for ensuring physical integrity of these assets and for ensuring business continuity, reducing costs, promoting sustainability, and enhancing adaptation in the face of various climate hazards and extreme events. This has been underscored by the United Nations Environment Program, identified the need to improve resilience in buildings as part of their Buildings Breakthrough Initiative. So what is IFC doing for resilience in the building industry? IFC joined the program aiming for near zero emissions and resilient buildings to be the new normal by 2030. To support our clients in the building sector, IFC has developed the Building Resilience Index, or BRI, which is a web-based hazard mapping and resilience assessment framework for the building sector. BRI aims to enhance urban resilience against climate and other natural hazards by mainstreaming resilient properties and improving transparency between the sector and stakeholders. The program achieves this by providing a standardized framework to assess, manage, and disclose resilience of buildings. It also generates investments for mainstreaming design, construction, retrofit, finance, and insurance of resilient buildings. And finally, creating an enabling environment to engage building sector stakeholders in resilient practices. And since 2022, the program achieved over 2 million square meters of floor space, which have been assessed with this BRI tool, and over $300 million of IFC investment commitment in resilient building projects. With that, let me turn over to Vanya. Thank you, everyone.
Thank you, Seth. Very clear introduction on the importance of our work on resilience. So I will invite now our expert, Aris Papadopoulos, who is founder and chair of Resilience Action Fund and is advisor for the Building Resilience Index of IFC. Ari holds the position of Distinguished Expert in Resilience at the Florida International University Extreme Events Institute. He serves on the board of the United Nations Alliance for Disaster Resilient Societies and was founding chair of the UN International Strategy on Disaster Reduction Private Sector Advisory Group. At the third UN Conference on Disaster Risk Reduction, Aris played a key role in developing the Sendai framework for disaster risk reduction. He's also an author of books and several studies, and I will let you go ahead, Aris, please.
Thank you, Vanya, and thank you, Deep, for inviting me to this distinguished panel. I hope you can see my slide.
We cannot see.
Not yet.
Can you see it?
Not yet. Not yet. Please maybe
Okay.
try one more time. Oh.
All right, let me try again. Can you see my screen?
Yes. Not. Oh, maybe now.
Oh.
It's coming, Aris.
Okay.
Now it's coming. Yes, we can
Okay.
see now what you're doing on
Okay,
your screen.
thank you. Again, thank you for having me on this panel. Thank you for that very kind introduction. I was going to say, oops, let me. This, I was going to, oops. Yeah, I was going to say a little bit more about myself. I'm an engineer by training. I spent most of my career in the construction industry. I've lived through 2 or 3 earthquakes in my paternal homeland of Greece and numerous hurricanes in Florida. I was also at the World Trade Center 9/11, and that kind of woke up the question in my mind: why are the assets weak? In addition to why are the hazards strong? I got involved with the UN Office for Disaster Risk Reduction, and as you kindly mentioned, was involved in creating the private sector initiative there, which is known as ARISE today, was the first chair. And upon retiring after 20 years as CEO of my business, founded the nonprofit Resilience Action Fund and also was appointed FIU. And as you kindly mentioned, I've authored a book. My second book should be coming out this year. It's been translated to Spanish and also an audiobook. And the book was inspiration for an international documentary that is publicly available. And a second documentary will be released this year. More information on my website, buildingresilient.com. So we've heard that economic losses in disasters are growing, but we may not realize that 90% of these losses are actually in the built environment. And of the built environment losses, about 80% are private. And of those private losses, about 70% are residential. So we're essentially losing our homes, which is the most vulnerable part of this built environment. What makes a building resilient? 2 elements. First, the ability to resist the hazard, which we call physical integrity. And second, the ability to continue functioning, which we call operational continuity. Measuring resilience has been a major challenge, but now IFC has through this innovation, leaped forward in that. Because if you can measure something, you can reward it, you can incentivize it, you can steer it in the right direction. However, measuring resilience, this metric has to be robust because we know that Mother Nature will test the resilience of buildings. But it cannot be so difficult. It's got to be easy to use, and it cannot be each building being a science, what I call a science thesis. So it's got to be easy to use, but robust at the same time. It can be a relative metric, meaning that A level is better than B level is better than C level. Who should know? Obviously, buyers and occupants should know, but also lenders want to know. Lenders rely on the buildings as collateral, and up till now have been relying on the insurance for those buildings, but they see that the insurance policies are only issued for 1 year. There's no guarantee in the next year whether the price will be the same or the terms, or even if the insurance will be available. Lenders, on the other hand, lend for 5, 10, and sometimes over 20 years and want to look behind the policy to see if the asset itself, the collateral, is resilient. And finally, communities want to know because they invest and plan in a lot of capacity for emergency response. And so knowing how many of their buildings are resilient or not is an important factor in that. The Building Resilience Index was developed by IFC to kind of complement the EDGE metric that measures energy efficiency and environmental footprint that was successfully developed about a decade ago. And BRI, as it's called in short, aims to identify risk, to manage risk, and to disclose risk. And I was proud to be a member of this team from the beginning, which was around 2021, and help lead and create a global expert panel that assembled the mitigation measures that we'll talk about later. So what is BRI? Basically, BRI is a verified self-assessment. We're asking the buildings to assess themselves, but then we're, as a quality control, we want these assessments to be verified by 2 locally registered engineers that rates any buildings. It's a rating, it's not a certification. The responsibility remains with the building and with the building's team. And it's for any building from small to large, residential to institutional to public. It's not for infrastructure, it's not for roads or bridges or dams, but any building can be rated. And finally, what we're rating are the hazard mitigation measures. It's not a rating of hazards, it's a rating of the mitigation measures of that building. I'd like to give this example. Here are 2 identically designed and built buildings. And in fact, both of them have one of the highest EDGE ratings, green certified. So should they be the same in terms of resilience? Perhaps not, because one in this case, the left one has one of the highest ratings, an A, and the other one on the right is the lowest rating, an NR. So how could that be? We have identical buildings, but they are in different locations. So the first location experiences relatively mild hazards, downbursts, some subsidence that it's addressed, and urban flooding, whereas the second identical building is facing hurricanes, earthquakes, and tsunami. So if the building was designed to just downbursts, subsidence, and urban flooding, and not for hurricanes, earthquakes, and tsunami, it will not survive the latter. So 2 buildings could be identical in EDGE rating, but opposing differently in terms of BRI rating because of the location. And obviously, the important thing here is the location determines how a building should be built. The hazards, therefore, are site-specific. Insurance data shows that over 85% of losses are due to 4 categories of hazards: wind, water, fire, and geoseismic, and BRI is organized around those 4. And under those categories are a number of hazard types. The top row here is what we call default hazards. In other words, any location will face these hazards. We've seen even deserts can have flooding. And the lower hazards are basically geo-determined. Some are macro geographic, like regions of hurricane or cyclone or tsunami risk zones. And some may be very microgeographic, like flash flooding that's dependent on the local terrain. BRI is a free and open source tool. Open source meaning basically there's no black box. You can see what's inside BRI, and you can understand why you are rated, what you are rated, and how you can improve your rating. The 3 components are the hazard knowledge that's incorporated into BRI, and that has not been completed for most of the countries. It's still underway. The mitigation knowledge that basically was the work of the expert panel, which essentially addressed what are the mitigation measures that are needed for the various hazards, and that knowledge has been completed and incorporated in BRI. And finally, all the user has to do is essentially input the building information, essentially answering the questions, does the building have or does not have each of the mitigation measures that BRI is calling for? And these answers then have to be verified by 2 locally registered engineers as a quality control. The mitigation knowledge essentially is grouped into a number of levels. Basically, for the very top level, the AA, the expert team looked around the world and said, what are the best global practices that have been proven in construction to resist hazards? And for example, we looked at the seismic practices in Japan as being the best global practice for earthquakes. We looked at South Florida for wind, and we looked at various mostly European practices for water and fire. And we kind of scaled down from there to an A level, which would be very strong practice or very strong codes. And then you have the moderate codes, which are the minimum we believe necessary to resist a hazard. And finally, at the bottom is weak codes or unpermitted development, which we know has a very high certainty of being damaged or destroyed. Now, building codes themselves, where do they fit into this? We know that building codes primarily have focused on life safety, in other words, getting the occupants out rather than preserving the structure. And therefore, in general, the A and AA will be above the codes of any location. The moderate B may include many of the codes, but may also not include some of the local codes in various countries. So we're hoping over time that local codes will also move up along this scale. And finally, we talked about operational continuity. There's a list of operational continuity measures, and presently, if you meet 3 out of 10, you can add a plus next to your physical integrity designation. The measures are kind of organized by category, hazard category, and some are location related, most are structural related, and a few are also inspection related, how the building was inspected during the construction. So I won't go through these. Obviously, this is the maximum number. Depending on your location, you may just have a subset of these for your particular building. Just to give you a flavor of some of the select mitigation measures at the different levels, when we look at high winds, we're looking at different levels of wind speed, and at the highest AA, we need to also be reinforced concrete, which is the global best practice. When we're looking at non-tsunami flooding, there are various levels here where the first floor has to be elevated above any local water, or the low point, maybe a dry creek and that presently doesn't have water. Fire rating is rated in hours for the materials. And then earthquake involves different levels of reinforcement, bracing, and finally, the best of the best, the seismic base isolation, which we saw recently in Turkey, helped a lot of the hospitals there survive the damage of that severe earthquake. So BRI rates each individual hazard category, but the overall building is given the lowest of the 4, which we call the weakest link principle, which in the first example here on the left would be a B, even though it's a AA for fire, and on the right would be an NR, even though it's a AA for water. But the other thing BRI does is it gives transparency and shows the building what they're missing in order to move, let's say, that fire NR to a B level or even an A level. So it clearly shows, these are the measures that you're missing, and perhaps the building, especially if it's in design, can incorporate those or can be retrofitted in some cases. The goal here really initially, in my opinion, is to eliminate NRs. And unfortunately, if you look at the building stock, and this is kind of my global estimates, most buildings today will be at the NR level. And even new construction will be probably half of it or a little less than half is at the NR level. And a lot of that NR level construction and existing building stock is what I call workforce housing, is the housing of low and medium income populations. The goal in my belief is to have zero in the future NRs, and obviously move the A's to AA's, the B's to A's, but even more importantly, is getting the NRs to be at least at the B level. So I would say, don't be disappointed if you're at a B level. Consider it a success for your building to not be an NR. I give this example here in Latin America, and these are kind of generally, general zones of hazard mixes. These are areas where seismic and hurricane, in addition to water and fire, exist. And we remember Acapulco, where they had built resiliently to earthquakes, but not to hurricanes, and therefore there was a huge amount of damage there. They neglected one of the major hazards. Then there's seismic areas that are primarily seismic in addition to water and fire. There's some hurricane areas there. And finally, the rest of Latin America is primarily water and fire hazards. Why this is important is because if you look at the investment that's needed to be made in buildings to go up this kind of, curve, the lowest cost is if you just have water and fire, and then it kind of grows as you add hurricanes, you add seismic, and then if you add both seismic and hurricanes, it's the most expensive. But notice here that the slowest part of that curve is this transition from NR to B. That's the low-lying fruit, and that's what we should be going after.
Harry, sorry, do you think we can wrap up in 2 minutes in the interest
Yes,
of time?
I'm in the
Thank
process
you.
of wrapping up. Yep, absolutely. So what do we need to get from NR to B? This kind of gives you kind of some examples of wind and water. In the best case, with the most mild, let's say, hazard types. If you go to the worst case, then you increase the wind and you increase the water level, and you also add a number of seismic requirements, which we know seismic disasters can be very impactful. Finally, I'll recap the terms of BRI. It's open and free source, any building type, verification by 2 registered engineers. The rating is valid for 10 years, or if a major event occurs beforehand, and it's a rating, not a certification. Also, BRI is being modified to allow ratings in progress. So if a building cannot do all its measures in one time, it can open kind of an application site and verify certain measures 1 year, and then add in the following years. And the global version is being developed, but it's been launched in the Philippines. It's being implemented Vietnam and Caribbean, and we're piloting in various other countries. Oftentimes the piloting is done without having the hazard mapping already complete there, so it may have to be done manually. Let's say, and then inputted into BRI. There's a manual worksheet to help in that. And this is a favorite quote I have from a gentleman in the Philippines, that resilience builds trust. If we're to have trust in our communities, trust in our institutions, we need to have more resilience. So thank you very much, and back to you.
Aris, thank you very much for that explanation. We are going to post the website of BRI for anybody who would like to test today. Okay, now I would like to introduce our next expert. Helena Colley is the General Counsel and Corporate Secretary of First Street. In her role, Helena serves as the primary advisor on all legal matters, guiding company policy to reflect legislative changes and statutory compliance. Helena has broad experience across the legal and business spectrum, with a focus on structuring strategic partnerships, commercial data transactions, and corporate governance. Helena is also recognized as a leader and frequent speaker on climate-related regulatory and disclosure matters. And before joining First Street, Helena was previously the president of Habit Advisors, an organization that provided workplace training in the areas of sexual harassment prevention, diversity, and inclusion. Helena, over to you. Welcome.
Thank you. Thanks, everyone. And I'm happy to be here. First Street is a public benefit corporation that provides physical climate risk models for every building, every structure within the United States. We launched about 8 years ago and have built since then predictive physical risk models for 5 different climate hazards, including flood, wildfire, hurricane wind, air quality, and extreme heat. So what I'll do today is just walk you through our public platform called riskfactor.com, and I will share with you my screen and take you through a couple of the different examples of how you can view what those hazards are as it relates to a specific building that you're looking at. As I mentioned, we are US only at the moment, but we are in the process of trying to replicate and build out these models in other jurisdictions as well. So more to come on that in the future. But basically, when you come to riskfactor.com, The homepage will allow you to plug in any address. We have residential buildings, commercial buildings, infrastructure, and also open plots of land that you can search for through the portal. So if I go to a home here that I use often as an example, each hazard will have a kind of quick and dirty score, 1 to 10, of just basically telling you, does this property have risk from this specific peril? So every peril has its own score, 1 to 10. And then some key insights for the property, whether there's a history of flooding or pollution facilities nearby, whether there's how it ranks compared to other properties in the state in terms of air quality. And then as you dig in a little bit more into the site, we have some backup details that will give you a lot more information. The flood overview looks out over the next 30 years and says, what is the risk of this property being impacted from this specific hazard over the next 30 years? So we look at it in 30-year, but then also break down into 5-year increments. So this year, there's about an 8% chance that any water, flood water, will reach the footprint of this building. We're looking at 1 inch right here, but you can also interact with the tool and change that, which I'll show you in just a moment. And then every 5 years or so, we break it down and say, over the next 30 years, what is the cumulative likelihood that some floodwater will reach the building over the next 30 years? So in this example, we're looking at 1 inch of flooding, but if you wanted to change it and say, well, what is the likelihood that 3 feet of floodwater will reach the building over the next 30 years? It will immediately update those likelihoods for you, and you can see kind of how the risk changes based on the depth of flooding. There's also a flood history. So has this property been impacted by a flooding event in the past? And if so, how much floodwater reached the property? So this property was impacted by Hurricane Sandy. It's on the East Coast. In 2012, there were 2.4 feet of water that reached the footprint of the building, the number of properties impacted. And then you can jump into a map view as well, which I will do in just a moment, and show you exactly what we provide on the maps as well. More information about maps that I will get to, community risk maps as well, that will show you things like what are the risks to surrounding properties like infrastructure or emergency services or schools, places of worship, things like that. So you can search in and around the area as well. And then some overall statistics about number of residential properties in the area that have risk, number of miles of roads that are at risk, and things like that. So you can get a better sense of the area. And the reason why we provide this type of information is that originally and continuing to today, this site is a tool for individuals. So people who may be interested in understanding what is the risk to my home or a home that I'm interested in moving to, so they can see, what obviously understanding what their current and future risk is sort of the first necessary but not sufficient step into creating resilience to homes and to buildings overall. So that's why we provide some of this information. And then the flood damage, so beyond just the exposure of how much flood water could we expect to reach the building, we look at what happens when water enters into the actual inside of the building. And that depends on a lot of different features, such as the building's first floor elevation, the square footage of the building, whether or not there's a basement, some of the building materials that are used. We also have this, as I mentioned, for fire and wind and air and heat. So for our perils like fire and wind, we're looking, when we look at damages, we're looking very significantly at what are the building materials, what is the roofing material, what are the windows, the siding, all of those things. And that we use the first principles of engineering to understand, based on that, what is the amount of damage that you can expect in different types of events. So for example, this building, this home is, the first floor is elevated 4 feet off the ground. So while there's an 84% chance that 1 foot of water will reach the property, there will not be any damage because it's 4 feet off the ground. No water will actually enter the first floor of the building. But when you get up to, for example, 7 feet, and we can show out a more specific chart here as well to show you exactly when you start seeing damage is when you get above that 4 feet level. Now you've got 5 feet of water reaching the building, so 1 foot will enter the building. And what is the likelihood of that happening? And if it does happen, what are the costs to repair and the estimated minimum days to repair? So we bring in that information here as well, but we want people to be able to interact with the tool and say, well, what happens if I, add some height to the property, and then you calculate that immediately in real time, you'll see that these damages change because now you're at 5 feet elevated, and so you won't have any damage until you get 6 feet of water to the building. Or whether or not there's a basement, or if you say, perhaps, this information is not correct, then you can update it here as well, and it will provide you updated details in real time. We're also looking at flood insurance and insurance in general, as that's a very big part of what we're dealing with now in a changing climate. Is insurance is getting more expensive and getting harder to come by for specific areas that are at risk. So we'll look at the FEMA zone. Our data is not based off of FEMA data. It is our own proprietary model, but we do pull in that zone for insurance purposes to understand whether flood insurance is required. What is the risk of rapid price increases? Is there a separate flood policy required? In this case, yes, because you are in the FEMA special flood hazard area, and other details about what is the estimated annual cost for insurance. And you can go ahead and get a quote right here from our site as well. Estimated change in insurance costs, and then some information about how to build resilience for your building, elevating the property, building flood barriers or dams in the area, sump pumps and other resilience or hardening options that folks will have. So let me jump into those maps again, as I mentioned, just to show a little bit more about what we have on the site. So we go by different return periods, meaning the likelihood that a specific event will occur. So our rare event is 0.2% likely in any given year. That's equivalent to a 1 in 500 year flooding event, right? They talk about a 1 in 100 year flood, a 1 in 500 year flood. So that's what this scenario is. And then you can toggle through to increasingly sort of less severe, more likely events, like a very regular kind of 1 in 2 year heavy rainstorm event, and see what is the max depth of flooding to the building. Right now we're looking at this year, but you can also say with a changing climate, we use shared socioeconomic pathway 245 for our maps here, if you're familiar with that kind of middle of the road scenario of how the climate will change over time. So in 15 years, that same event, while it's causing 5.2 feet of flooding now, could reach 6.3 feet of flooding in 15 years to the property, and 7.4 feet of flooding in 30 years to that property. And if you wanted to get into the more likely, less severe event, you can also toggle around. You can see the outline if you zoom in where the trajectory of the water is going. So it may not be getting to this particular home itself, but you'll see a lot of roads are impacted, and you can understand a little bit more of what you can expect in the community. You can look at a satellite view as well and zoom in and see where along the property's footprint can you expect to see the floodwater. Looking at historic risk as well, I mentioned that this property was impacted by Hurricane Sandy. So we've recreated this flooding event to see where the water reached. And you can do that with the different events that we've recreated. And then we look at community risk as well. So if you wanted to filter out to say, what are the social buildings within the area that have risk, those include things like schools, museums, government buildings, places of worship, things like that. And you can also filter by the risk level. So if you're interested in every type of building or only the ones that have, let's say, major, severe, or extreme risk. And then you can search by different regions, so county, neighborhood, zip, or city. And then you can toggle on to any of these properties and see this is a museum, it has major risk, and if you click through, you'll get all of the same information for that property as well. This is another museum, lots of museums in this area, but things like that you can get more information about the community. And then the last feature, which is one of our newest features on the site, are protections. So is this property protected by any flood adaptation measures? There's a levee nearby. There are 9 different adaptation measures here, so you can click and view them on the map and see what are these different adaptation measures and how many properties are impacted by that specific adaptation measure. That's the kind of main crux of it. We also, as I mentioned, have fire, wind, air, and heat that function largely the same. I don't know, Vanya, how I'm doing on time, but I can jump into.
Yes, maybe we have to wrap up so we can let the next panelists and also allow for some questions. People are already posting questions about First Street.
Sure.
So
Absolutely.
Is that okay?
Yes.
Thank you very much, Helena, for this overview about First Street. So I'm one announcement for the participants, please. We will be shortly sharing a survey for you to evaluate this event and give us feedback. If you can do that, we will be very thankful. So let me introduce our panelists from Swiss Re. I will start introducing Sam Gabal. He's a senior executive vice president and has over 20 years experience working with insurance claims and policy software solutions with roles ranging from system implementation through technical pre-sales and new business development. Sam joined Swiss Re in 2023 with particular emphasis on data and insights for NatCat exposures, climate and nature risk, and their impacts on property portfolios and supply chains. Together with Sam, we have Rodolphe Bouquet, who is head of sustainability solutions at Swiss Re. Rodolphe brings over 10 years of experience in product and business development of sustainability risk assessment analytics software, both in the corporate and startup environment. During his career, he has also been driving public climate policy development and implementation for several French public authorities. He has served as an expert on several advisory committees on sustainability, for instance, the European Financial Reporting Advisory Group, Principles for Responsible Investment, and the United Nations Finance Initiative. Colleagues from Swiss Re, please, over to you.
Yes, thank you for that introduction, Vanya. And I will actually be sharing my screen here for Rodolphe to lead an intro. So bear with me 1 second. And start the slideshow. Okay, Rodolphe, over to you.
It's coming.
Perfect, thank you.
Perfect. Thanks a lot, Sam. Hi, everyone. I hope you hear me well. Perhaps to make a connection with the previous presentation, Swiss Re's solution, which is called Risk Data Services Platform that we are going to present, is dedicated not to individuals, but to private companies. And the aim of this platform is to leverage the internal risk model that Swiss Re has been developing over the years for its own needs as a reinsurance and insurance company, and make it available for companies to assess the exposure and vulnerability of their real assets under different climate scenarios. So there are more than 190 models that are leveraged to feed into this tool. So how does it work? First of all, it's a tool that can be used for different types of real assets. Of course, buildings, that's the main topic of our discussion today, but also solar farm, wind farm, plants, roads, forest, construction sites, and other type of infrastructure. What is important is that each type of building is assessed in a different ways. It will relate to different vulnerability curves. And within the same type of building as well, the level of information that is provided, similarly to what was said before, like the structure of the building, its occupancy, the defense measure that have been integrated will also impact the vulnerability curve. So this is quite granular on the way we ingest data about each specific asset. When we look at asset, the type of insight that we provide back to our clients are to characterize the exposure and vulnerability, both for the present situation and for future situation, depending on different climate scenarios. And there we rely on the main scenarios from the IPCC, corresponding to different average temperature increase in the future. And you can use this different scenario at different time horizon up to 2080 and the end of the century. The type of risk that we look at are twofold. The first one are natural hazards, including those that you can see on the screen, floods, of course, wind, different types of storm, volcano, earthquake, lightning, and others. So natural hazards on the one hand, and the other hand is what we call nature-based risk. So this is the ability of ecosystem to contribute to people and to support economic activities. And there we have developed a proprietary methodology which breaks down into 10 dimensions of these ecosystem services. And for each location, we will assess the asset dependency of this on these ecosystem services and the asset's impact on the ecosystem services. So we will provide you, while using the tool, with an understanding of your exposure to the risk, but also your vulnerability, and providing financial quantification for your risk exposure. So we can move to the next slide. Sam, please. So the way it works is that the user is going to input data about the different assets it wants to assess, and then a digital twin will be created in the tool. And this digital twin is going to be enriched by different types of information layers. And then we will feed back to the user either at a location level or at a portfolio level, a portfolio being an aggregation of different assets, the result of the assessment. And this tool is a platform, a SaaS platform, which works on a subscription basis. And it features all the kind of security and connectivity features that you can expect from such a tool, including some automated reporting to fulfill regulatory disclosure that you might face, and to export data. One thing that is important is that it's a global tool, so covering all land and all continents. And it's a granular tool, starting from the asset level and then aggregating a risk assessment for different portfolio, which can be geographies, business units, companies, depending on the way you want to structure it. We can move to the next slide, Sam. So there are different use cases for this tool. One, of course, is to provide information that can enhance risk assessment models. So that can be useful internally, but also for financial institutions and investors to augment their credit risk assessment, to monitor portfolio risk, and in some instances, to conduct some climate stress testing of investment or lending portfolios. And one of the metrics that we provide is the annual expected loss for a given asset for each type of peril and different types of climate scenario, and also the loss curves for different perils under different time horizon. Can move to the next slide. As I mentioned, one of the very common use case of the usage of this tool beyond risk management is sustainability reporting. There are different types of framework under different jurisdiction, but they share some common features. And by using RDS, be it for climate risk quantification and reporting, or for nature-based risk reporting, RDS provides a lot of useful information that can support this reporting. And one part of this reporting process, which is important, is to assess the materiality of the risk that you're facing. And of course, the quantification that we provide for the risk assessment is a key component to assess that materiality.
I think Rodolphe was at the last of your slides.
Yeah, I believe so.
Okay, so bear with me, folks, while I re-share my screen. I'm going to pull up the RDS application for a better look. And here we go. Okay, so hopefully you're all seeing my window of RDS. Is it coming across on your side? You should see a world map in the center of the screen. Great. So as Rodolphe mentioned, the system is really designed to work around a digital twin that will load up for any of our...
Wait a second, I see a gray screen. How about you, Rodolphe?
Sorry.
Yes,
Let me...
I see also a green screen on top of Sam's screen. I don't know why.
Okay.
Maybe Sam, you can try to
We could see at the
reshare.
beginning of map, but something gray came up above.
Okay, I'll try once more, and it's a good thing I have some slides as a backup. Okay, so it looks like I'm having issues with the...
Yeah.
All right, so we'll go back to sharing the PowerPoint, and I have slides that I can show instead. So where are we? So I was mentioning very quickly, hopefully now you're seeing the world map on a slide. Yes, so
Yes.
before we even load up a digital twin, we can do some rapid scoring, but what you see on screen here is a representation of a whole lot of plotted points. So each one of those individual points would be an asset that's part of a portfolio loaded into the system as part of a digital twin. There's a number of filtering tools over to the left that can be used to drill down to any of the locations you want to take a look at. But before even loading that digital twin, we can do what's called rapid scoring. So the system gives you tools to display the different risk zones, the perils, by toggling them on and off with the controls over to the right. You can zoom in and look at any real part of the world, looking at those specific perils to see how those layers stack up. Also along in that same sort of concept, you can very quickly either drop a pin on a particular location or draw an entire polygon to get what's called a rapid score of each of the perils. As you can see on screen, we have the different Swiss Re perils all listed here. Most all of these are Swiss Re proprietary perils. As Rodolphe mentioned, we also have the ability to bring in the official zone. In this case, in this part of the world, looks like there's no official zone data available, but for instance, in the US, this would be FEMA data that we'd be showing. The significance of the polygon there is great because if you're straddling more than one region, more than one risk zone, we can take a weighted average of all of the points under, or 100 points under that polygon to give you scores that are more relevant to the entire region that you're looking at. To keep going, and we'll go quickly, I know in the interest of time here, we're looking at a location here up in the Nepal region. For a location that is already loaded in, you can see then each of the different scores, and we have them stacked up by category. So we have each of the flood layers displayed here. Currently, I'm looking at the fluvial flood. behind the scenes there, and you can see the polygon that's represented for that entire property. And then we also have some storm categories and the other hazards here, which are wildfire, lightning, volcano ash, and landslide. So these are basically measuring different measures of the resilience, the exposures to these different hazards for any location that's loaded in. Along those same lines, besides the exposure to the perils, we have what's called climate risk scores looking forward over time. So we have the 3 of the different scenarios built in, SSP 1, 2, and 5. We are soon to be adding SSP 3 due to high customer demand. So you can click on any one of those tabs and the system will then display what is the expected intensity of change going forward on a normalized scale of 1 to 10, and it's color coded to go along with that with that number scale. And besides just the expected level of change, we then take that and apply it to the current, or what we call the historical level. So over time, for this particular location at SSP2, we're not expecting a whole lot of change, but you can see pluvial flood that does change from very high to extreme beginning in 2060. Similarly, extreme precipitation following that same path. And then we're moving from very high to extreme pretty soon here on the heat wave category. And down at the bottom section, you can see that for most of these measures, we're also giving you an actual number representation and in the relevant sort of measures. So, for temperature, we're looking at degrees Celsius. For drought, we're looking at maybe number of days. So moving right along, we also have here what we call nature risk. This is the biodiversity and ecosystem services that Rodolphe mentioned. So in this particular case, it's an electric utility, and based on that activity, we're able to then assess what the dependency is of that on that local environment, as well as what your operational relevance is. So the first column here really represents what the natural state of the environment is at that location, and then it factors in that activity to calculate the dependency, as well as how that activity might put the local environment at risk. Finally, we have the loss quantification, and that takes into account really everything that we know about the building. The primary factors we're looking at are, of course, where the building is situated and how it's exposed to the different perils. And then what is the occupancy of that particular location, as well as structure type, and a number of secondary modifiers, things like flood protection and elevation, whether it has a basement, lots of different protection or COPE data factors that we can take into account to then calculate what we call an annual expected loss. So this is not a prediction of the actual loss, but it's on an average year, what you might expect in terms of annual expected loss for that particular location based on everything that we've loaded about that. And finally, the system's able to produce a report which really summarizes everything and formats it nicely. It's a very simple process of selecting the location, exporting the report, and choosing which sections of it you'd like to include. And in the interest of time, I'll just very quickly show that we have these same sorts of metrics, or I should say, more detailed analytics for those same measures, in this case at the portfolio level, where you can look at how each of the locations within a portfolio stack up and compare to each other. In this case, it's a natural hazard analysis. Here we have the accumulation risk or the loss calculations, and these include even the dollar amounts expected to be lost for the specific return periods per peril. So final thing I'll mention very quickly, we also have the ability to take a look at historical events that have occurred and how your locations that you're assessing might have been affected for that actual historical event. In this case, we're looking at a flood called Danielle from 2022, and it shows you the locations that were at risk from that. So I think in the interest of time, Vanya, I'll wrap up there.
Thank you. Yes, I will pose 3 questions to the 3 groups of panelists. For Aris, the question is, what is the relationship between BRI and EDGE? For Swiss Re, the question is this tool also available as open data for users to play with it? And for First Street, they asked what is the source of the flooding data and whether the tool can be used in other countries than the US. So maybe we will start with Aris answering, and then we will go to Helena and then Swiss Re.
Yeah, thank you, Vanya. Well, Edge and BRI are two separate metrics, each done in its own methodology with its own application. The objective obviously is to have buildings that are both high on Edge and high on BRI. But there's no guarantee that a building that's high on Edge will be high on BRI, so they have to be done separately. But to be sustainable, you need to be high on both, eventually. So, and IFC very, very correctly, in my opinion, made these separate indices because there've been kind of a lot of indices that have tried to combine the two. And in my opinion, you cannot combine the two. So I applaud IFC for separating them and making them two parallel metrics. Thank you.
Thank you, Aris. Helena, please go ahead with your answer.
Yes, so when building our flood model, we collaborated with over 80 experts in hydrology and climatology and a lot of different fields. And we relied on both publicly available government data like NOAA and data from NASA. And then we also have some private data that we license that allows us to have access to some of the tax assessor data like building materials and things like that. So it's more information. You can read all about the methodology. We make everything transparent. So if you go to, I'll put it in the chat as well, firststreet.org/methodology, you can see all of the details about how our models were built. And then the second question about US only. Currently, we are US only for fire, wind, heat, and air. We are the continental United States, the lower 48. And then for flood, we also add Alaska, Hawaii, and Puerto Rico. We are growing and are building out international models. But at the moment, we are US only, yes.
Swiss Re, please go ahead with your answer.
I think it's a simple answer. It's not currently publicly available. We're happy to engage, of course, with anyone with specific questions and even to do a quick study as a preview of a particular location. And I'd encourage you to reach out if that's of interest.
Thank you very much. So we are at the end of the webinar. It was extraordinary to see all these experts. Thank you for your time and have a good afternoon, evening, wherever you are. Thank you.
Thanks for having
everyone.
me.
Thanks a lot.